So good afternoon, everybody, and warm welcome to all of you on behalf of Francesco Pignatelli, ELISE Action Leader and the Senior Program Manager at the Joint Research Center of the European Commission, as well on behalf of Alexander Kotsev and Marco Minghini, both Project Officer and Joint Research Center, and also responsible for the API for Inspire activity under the ELISE Action, and myself, Simon Vrečar, external consultant and Joint Research Center as well, who will be together co-hosting this ELISE workshop, SensorThings API brings dynamic data to Inspire. So before go to the workshop, let's speak a few words about ELISE for those who don't know. As you can see on the next slide, so ELISE stands for European Location Interoperability Solution for e-government, and is an action part of the, as an action part of the ISA Square program, which is one European interoperability program aiming to provide cross-border and cross-sector interoperability solution for public administrations, businesses, and citizens. There are 54 different actions tackling interoperability from different angles, and ELISE is actually the only one amongst them focusing on the location dimension. Within the context of the ELISE knowledge transfer activities, as you can see on the next slide, we are organizing periodically that kind of webinars or workshops, which aim is also to engage in an agile way with the topics of relevance to the digital transformation, and as well to promote the consolidated results of ELISE action activities. So that will be also the aim of today's workshop, in which we will present the results of the API for Inspire activity, which was supported as well by this ELISE action, and was investigating actually the new developments in geospatial standards and technologies, in particular the new OGC API features and OGC SensorThings API. So we have today two speakers with us, as you can see on the next slide. One is Kathi Schleidt, an Inspire expert from DataCove, and Hylke van der Schaaf, SensorThings expert from the Fraunhofer Institute. So what they will cover today, as you can see on the next slide, the workshop has been designed in several blocks. So it has been designed in the way that could address a wide range of participants. In the first block, it will be provided a more high-level overview and of the power, in particular, of the SensorThings API, which will be suitable to wide audiences and interested to understanding more about the potential of this technology. So after about 1 hour, this overview, the short break will be made, and after that, you will be diving, let's say, deeper into the technicalities of API deployment and use. And maybe at that point, even less technical participants may wish to leave or attend only the first block. So from this point on, I will leave you in the hands of Kathi and Hylke. So Kathi, please.
Okay, good morning. Let me get my overview of the buttons. I'd like to welcome you all to this workshop, and I would like to start off with a short survey. So let me see if I can get the other screen over here where I'm presenting. Could everybody please go to menti.com, use the code shown up at the top, and we can start doing a few initial questions so I get a better overview of who really the audience is. So the first question is, who has ever used an API? Does the audience even know what we are talking about? Hey, cool. Okay, so this is not just something very nice, or we have the right audience. Okay, it's getting more and more. Okay, we've got a third person who we need 4 people. Very good. There's a reason why I put in some slides on what is an API. Let's see, votes are still coming in. Try and gauge how many of you are being good and actually voting. We now have 40 of 47. I'm not voting, my co-presenters are not voting. I'm going to assume 41. I'm still going to assume right now that this slide, most of the audience does know what an API is, has used it. A few are still a bit lost. Those we will pick up and explain this to. Thank you very much for this bit. And the next question. Which APIs are you familiar with? Okay, it's an interesting spread. We see Germany is right now ruling with Deutsche Bahn. Can any other countries step up? Well, okay, OGC is finally in the middle where it belongs. Getting ever more central. REST APIs are becoming a relevant concept. As REST is coming all over. Interesting is to focus on transport. We have both the German railway and the next bike. But in a way, it's clear. It's spatial. Okay, I would say this is settling to the people who are familiar with APIs. We nicely see OGC is at the center of all of our concerns. There's a strong focus on REST that comes up in several places. But it's also interesting to see where it goes. We've got it all the way down to Sparkle and whoa. Okay, so we also have a very nice spread of what APIs people are familiar with. Which software solutions have you used for this? Python rules for the moment. Let's see how this continues.
We have some very technical people in the audience.
Okay, you have a good audience waiting for you. I feel sorry for the poor little R and it's getting lost in there. Somebody should have capitalized that so it has some presence. Okay, are we settling? Do we have consensus that somewhere up? No. Python is getting stronger. GeoServer and Java are holding their own. And then people start getting creative. I have no idea. I totally get, yes. Okay, but it means we do have a fairly technical audience out there waiting for us, and we are going to have fun this afternoon.
That's good.
Okay, that's the end of the first part of the survey. That was to give us a basic feeling of who are you and who are we talking to. Now I will start talking to you. And so a quick overview. This is just now the first block of a basic intro to what is all of this stuff. I'll be starting with the background, a very short bit on Inspire, and also as promised, what are these APIs? Then I'll do some more in-depth information on what we are doing in the API for Inspire project. This includes the project goals, the evaluation methodology that links to our goal of evaluating both OGC API features and SensorThings API for use in Inspire. And then I'll also be showing you, we've been setting up a whole set of various different endpoints. We'll be focusing on the SensorThings endpoints in this webinar, since that's the focus of today's talk. After the background, we'll then go into a more in-depth overview of dynamic data and SensorThings API. We'll give you some detailed information on what is really this observational data and why is it different from normal spatial data. We'll then go on to the SensorThings data model. We'll show how we've aligned that with the INSPIRE environmental monitoring facilities data model. So all data which is foreseen for INSPIRE environmental monitoring facilities can be perfectly provided via SensorThings API. And finally, we'll then go, I'll show you the details of some of the request patterns, and then we'll go into a discussion before we have a break, and then go into the really detailed bits. So starting with the background. Okay, there we've got the survey code again. I should have put that on the previous slide. You would have had it, but you had it anyway. Okay, what is INSPIRE? I'm going to just leave this here for your reference. I think anybody who's here knows it. It's a directive from 2007 on establishing a European SDI. There's a whole set of OGC-based UML models for the 34 spatial data streams. And I'm not sure if the current status down there is correct. I'm sure it has been rapidly rising with this fall's deadline. But it is seriously impressive how many data sets have come online, but at the same time, also some of the issues we're now trying to sort with the introduction of APIs. So going on to what are these API things? We're focused on the OGC APIs. API is a wider context, but within the spatial domain, basically all we're concerned with are what is OGC bringing up here. I'm assuming you're all familiar with OGC and OGC web services. They've been around for decades, and they're not the simplest thing to really use in daily life. So even people who are very familiar with them have to keep checking the handbook. How does one formulate this? How does one do this? So APIs is a new type of services which is now been identified for use within the OGC. They're web APIs, often referred to as RESTful web services. Each service is described by a basic open API, or actually within SensorThings a bit differently. This is trying to cover both OGC API features and SensorThings. But the nice thing is that the API service endpoints are self-describing. They're all geared towards JSON-based representation of resources. That tends to be the default encoding. However, in contrast to the old OGC web services, it's fairly easy to request different other encodings. So you can get the same data which you access as JSON. You can request that as XML data if your data systems can parse that better. You can request it as an HTML page and just take a nice look at it. So it's getting much more user-friendly. And also each of these API services, they've got a minimal core of what must be done. And then you can add various extensions for additional functionality. The OGC APIs, they're well suited for basic spatial features. This is a no-brainer coming from OGC. If they're not good for spatial stuff, they're not coming from OGC. What they're missing is the support for more complex underlying data models. The query functionality is still being defined, and we're still seeing issues when dealing with dynamic data. And that's why we have been focusing on the OGC SensorThings API, which it's a bit different from the general OGC APIs. It has far cooler query logic. You'll be seeing all of this in detail in the course of the afternoon. So you've got all of the advantages from the existing OGC APIs and quite a bit more. Now, why do we need these in INSPIRE? Current state of play, we've got all of the OGC web services. Everybody has been busy setting up their web feature service, web map service, and the like. But they are so hard to use. And APIs have been showing up on the scene progressively over, I'd say, the last decade. So the core OGC APIs are now being finalized. The SensorThings API, which we're working on, has actually been finalized since 2016, which makes it one of the most robust of the OGC APIs, because this has really been in operation and tested, and we've got multiple implementations, so it's becoming a very solid standard. And we've been since we've seen the potential of this for use within Inspire, we've been doing the work. We have candidate Inspire good practice status for it. Ideally, based on today's workshop, we will then get the final certification at the upcoming MIG meeting, and then we're basically good. One of the reasons for this workshop. So a bit wider context, why APIs in Inspire? It's also triggered by a lot of the background European agenda. I mean, the people over-focus on Inspire see Inspire as the world. Inspire is one small piece of a much larger European infrastructure. What all types of data do we need to make commonly available? So I've put up a list of what are the relevant activities currently happening within Europe. We've got the European Strategy for Data. How can we get various sector-specific data spaces and then also connect these? We've got the Open Data Directive to really ensure that high-value data sets are there, they're documented, they're harmonized, and people can use them. We need this data, and with APIs, we can make them far more easily available for wider uptake. We've got the Digital Europe program, which is trying to improve Europe's competitiveness in the digital sector, push back against what the other continents in the world are doing. Inspire goes on in the next 4 years, so the MIWP program continues 2020 to 2024. What we have currently in Inspire, we modernize and update it. Partially the introduction of the APIs is a part of this work. And we also have the Next Generation EU, which is really trying to see how do we rebuild a post-COVID Europe that'll be greener, more digital, more resilient. How do we make the best of the bad situation we're in and come out better? Further on why APIs and Inspire. Okay, so getting back down to Inspire, it's a beautiful opportunity just to increase the use of the infrastructure, somehow leverage Inspire into mainstream IT. It's still been too much silo-based. One has Inspire as a spatial domain, one has other domains. They still don't talk properly. These should be cross-linked and cross-discoverable. One of the advantages of the APIs now being introduced to Inspire is they all follow the various data on the web best practices and spatial data on the web best practices stemming from W3C. So this will help to integrate them into the wider data community. And we're also leveraging grassroots standardization of seeing what do people really need, how can they creatively take these technologies and make them work for them. And so we've been trying to work through hackathons, through various early implementations, co-creations of specifications. We're trying to really see what can one do with what we've made available to date. Now moving on to the API for Inspire project. This has been implemented under the ELISE action of really trying to ground truth. I mean, we've seen all of the potential for APIs in Inspire. How does this fit to reality? And so the demand we've seen, the various European initiatives are pushing for this direction. We've got various curious data providers, but we need to know, is this just a good idea, or can we somehow prove that this good idea is really a good idea? And for that, we've set up the following tasks you see on the screen. We've defined an evaluation methodology, which really goes through all the aspects pertaining to the APIs, their deployment, their use, and try to work out where are benefits, where does one have extra effort, so how does it help, how does it make life better or worse for us. We've been developing deployment strategies for how to really best deploy both OGC API features and SensorThings API within the Inspire context, how to make this easier for people. We've been with our associated data providers, we've been deploying all sorts of API endpoints across both API types and making these available. We'll show you these during the presentation and also show you the website where they're all available. during this process, we've been learning lots of lessons of what are the tricky bits, what is easy, what is hard, where is support missing. So based on that, we've been creating a lot of guidelines and basically tutorials, how to. They've all been emerging on our site, and Hylke will be walking you through quite a bit of these during the afternoon. And finally, we want to provide evidence for Inspire that SensorThings really make sense as a good practice with these APIs and get these finally certified. So project partners, API for Inspire project, the lead is Fraunhofer IOSB. Hylke von der Schaaf is going to be then presenting the details of this. And they're also involved because they have been developing the Frost open source SensorThings server, which is, I think is right now the reference implementation at OGC, and it's one of the most stable and widely used servers for the provision of SensorThings API. Second partner is DataCove, that is myself, that is bringing in the Inspire expertise and background. Third partner is more focused on the OGC API features aspects. There we have GeoSolutions on board and have been working on extending GeoServer for the provision of OGC API. That's a different talk. We'll be holding that at some point shortly. Going on to our data providers, we've gone through and tried to find representatives of different types of both normal spatial and also dynamic data across Europe. And our current list of partners, we've got the Austrian Meteorological Agency on board. They're providing their meteorological data via SensorThings. We've got Austria Control, who is providing all of the air transport data via OGC API features. That's all online and available. The Austrian Environment Agency, we pulled in Ad-Hoc together with the European Environment Agency. This came up during the spring when, in the course of the start of the COVID outbreak, we started seeing more and more publications and research happening on the links between COVID intensity and ambient air quality. And since one of my backgrounds is working with European air quality, I defined the European air quality reporting requirements. So I know exactly how is the data structured, where is it, and how could we make this available via SensorThings API. And we were locked down anyway. We were a bit bored. So a few weeks later, we started importing the Austrian air quality services coming from a sensor observation service and the WFS. Got those packed into SensorThings, and then common demand across Europe started showing up saying, actually, why don't we have this for other countries? So we got access to the EEA's data sources, have started importing that, and have been providing that in real time down to the last hour since last spring. Further bits, we've got the city of Hamburg. They've got a very nice set of smart city sensors. We've got a lot of traffic sensors there. Then we've got BRGM, the French Geological Survey. From then we have mostly water data, ground surface, quality, quantity. We're also going a bit into the flood risk zones there. They've joined jointly with the French Office for Biodiversity. So they were also extending some of these prototypes towards biodiversity systems. Finally, we've got the Environment Agency for Baden-Württemberg. They're again providing water, surface, ground, quality, quantity, all on SensorThings, which allows us to do some nice cross-border work. Now, going into details of our tasks. As mentioned before, the first bit is defining an evaluation methodology for how do we gauge the usefulness of APIs within the Inspire context. This was quite a challenge because there are many evaluation methodologies out there. Almost none of them apply to APIs. We did find a few and managed to merge those with others. We'll be providing the details of those in the next sections. Then we created development strategies for both API technologies. We've been deploying all sorts of API endpoints with our data provider partners. We've been providing various guidelines and technology support and lessons learned from this process. And we've been working on getting the Inspire good practice status for both of these APIs sorted. So focusing on the evaluation methodology. What is the goal of this? The goal is to understand what are the impacts and benefits of APIs as a valid Inspire download service. And also, which I haven't mentioned yet, is to a certain extent simplifying the Inspire data models. What do we really need? What is excess baggage? Could one maybe split some complex features into multiple simple features? So also analyzing a bit, are the data specifications as they stand fit for purpose, or could one, still fulfilling the IRs, providing the full breadth of the data, do this in a simplified form? So that's more focused on the OGC API bits. That will not be further discussed here. Then we've got what are evaluation dimensions. I then started referring to these as our degrees of freedom, that some things are given. The Inspire regulation is laid down in European law. We can't change that. What can we change? So we can influence the API specifications. OGC API features is still in the process of being finalized. SensorThings API is finalized, but also there, all standards continue to evolve. And one thing we've already changed within the SensorThings API specification is we managed to there open up the data model a bit so that we can provide the full data breadth, which is required by the Inspire implementing rules. One of our strong features there is that Hylke is co-chair of the OGC SensorThings working group. So if we're missing something, we have a very strong proponent to get that integrated into that standard, as we've done. Second degree of freedom we have pertains to the data model. As I was stating, that one knows what is legally mandatory from the IRs, but one doesn't, according to the legal text, one doesn't have to provide it in the structure of the UML models. The content has to be there, the structure is up to the data provider. So one of our degrees of freedom is seeing, are there ways of subtly modifying the data model, maintaining the full breadth of the data contained, but making it easier for technologies to provide. And the third degree of freedom, where we've got a way of influencing this, nudging it towards the better, pertains to support ecosystems. That's where I mentioned we've been creating all sorts of guidance documents, tutorials to make it easier for people to implement these technologies. Been trying to sort of fill the gaps we've been encountering and put documentation there. Finally, to the evaluation methodology, what are really our components? We have various stakeholder perspectives. So who is using all of these technologies in various ways? As a second component, we've got the evaluation criteria we're evaluating against. And at the final point, we've got the evaluation methods, which we apply to analyze one criterion from one stakeholder perspective. And pulling all of those three bits together, we pull together the stakeholders, the criteria, and the methods, and that is what becomes our evaluation process. So starting at the top, starting with the stakeholders. Who are stakeholders? First step was going through and analyzing the known suspects. Here's a list. I'm not going to read it for you, but I think it's fairly comprehensive. If somebody's aware of something I missed, please feed that back to me. I'd be curious if there's a stakeholder type which I haven't found here. Based on these stakeholders, we then went through and tried to see, how do they provide data? How do they use data? So we made a nice matrix for each of our stakeholder types. We checked what is the provision spectrum, or the provision type, what is the usage type, what are potential impacts. Then we summarized that to get an overview of what are the relevant aspects pertaining to provision and to usage. So pertaining to provision, one of the major problems is configuring an existing data system for the provision of this API. That's an eternal hassle. One of the things, okay, here's mostly focused on, again, the OGC API features. We've been doing too many talks of both of these. So pertaining to that, we've been working both with Geo solutions to extend what GeoServer can do pertaining to OGC API features. We've also actually done a very simple implementation one can use for simple features just to really get a proof of concept. How hard is it to implement this API? Pertaining to SensorThings, our main push is just to get this certified so you can use it, because as stated, the technology is already there. Frost is a stable system, has been running for years, and there are various alternative implementations also available. Usage spectrum. What are different ways people are using data? And this is now not based on APIs. This is what are they doing at present? What should we replace the APIs with? Or the current, what do the APIs replace? So, I mean, in many cases, people are within their institution still just directly accessing the database. That's a common way of doing it. It's the most effective way of doing it. It's not really good for data sharing. Similar to that are the file-based data sources. I'm sure you're all familiar with all of the shape files fluttering from desk to desk in various versions, and which is the ultimate version, nobody knows. But it's the status quo, it's how people are currently working. Some people are working with OGC web services, but just utilizing simple features. That's still fairly common. Where less and less people are working is accessing OGC web services with complex features, because they were already missing a bit of the tooling. Access to REST-based APIs, some people are already adopting this. Some are still learning, but I think that gives us an overview of what are stakeholders using at present. So these are the type of both provision types and usage types we need to be able to support by our emerging APIs. Further analyzing the stakeholders, we then broke it down to 3 clear stakeholder perspectives. We've got the very advanced stakeholders who actually develop their own API for the provision process. They might take a few libraries, but I think this is the Python contingent, which we saw at the initial survey. They have their database and they will write something to provide the API on top of that. The second stakeholder perspective are those who are going to be deploying their data, but by utilizing some existing software. So they're deploying either Frost or GeoServer or some other software. Then they're configuring their data sources to be provided by this endpoint. The final stakeholder perspective we have pertains to usage. So this is the pure data users, concerning the role of API users as data consumers. So this has strongly influenced how we've now been further analyzing the various usage of the data. Is always reflected back on the stakeholder perspectives. Going on to the evaluation criteria. As I mentioned, it wasn't easy to find anything on evaluating APIs. It's partially due to the fact that APIs are still a fairly new concept generally within IT. Some of the literature out there actually refers then to API in the old sense of application programming interface. I mean, we had this term in the 90s, but we used it to refer to a C library. That's something very different from the current usage of the API term. But we did find one very interesting publication, which it describes a 5-level open data API evaluation. It's based on Sir Tim Berners-Lee 5-star deployment scheme for open link data. And based on everything we found, this seemed like the most solid evaluation criteria, which is really looking at APIs. To make sure that this really covers all aspects required, we then did a cross-analysis with the ISO 25010, which is a standard on systems and software engineering, and is really focused on the quality requirements and evaluation. Based on that, we got a few insights and either adjusted some of the existing criteria or also added new ones. And a further source was just the project partner's experience. If there was an aspect which we saw missing, which we said is relevant, we added it. So what does this evaluation system consist of? Yes, presentations will all be made available afterwards, and you can read them at your leisure. That's why I'm not reading everything directly out to you. You can read it afterwards. So going through our evaluation criteria, as I said, it has 5 levels. Level 1 is the very simplest. It's been referred to as all fine within the publication, and it comes down to the basic criteria. Is there a single entry point where I can get all information I need on this system? Is there clear, up-to-date documentation? Are there example requests available? Is there example data available? And is it possible to discover this service? That's the first level of questions. Second level is referred to as all used. Here, the criteria, the one is, does it provide the data in JSON or XML, which are sort of the most common formats, or is it providing the data in some obscure proprietary form? Are data license information clearly available? So do you know, can you use this data for what purposes? Related are also the terms of use. Is that really clearly expressed, easily accessible? Is relevant metadata about the data embedded within the data, or does one need to somehow discover that separately? Authentication pertains to if the API supports some sort of authentication or authorization mechanism. Is the API standardized, and is the API suitable for the intended use? That's second level. Third level is now already, we know this is a fairly stable basic API, but it's getting more detailed. Is there really a query and analytics API? Can one sanely query this data, or can you just point to an object somewhere? Is there solid error handling in place? And can you find out what does that error code mean? What are you doing wrong? How can you do this correctly? It makes it so much easier to learn a new system. Is the performance up to what you need? It doesn't help you having a great system, but it takes an hour to get a response. Caching is related. If caching is nicely implemented, then if you have many requests, caching takes care of a lot of them. Background support pertains to, is there really a wide community available? So can one expect support? Can one expect further developments? Are tools available? Can one easily integrate this into an existing workflow? And finally, can one validate the data that is being returned? Or does one just have to trust that this won't break one system? So this is already a fairly mid-level level of maturity of an API. All involved is not getting fairly professional. Is there an SDK available for, at least for one environment, ideally for more? Are there code examples available across programming languages? Is there really a growing community to consult if needed? Do you need to consult one expert, or can you go to Stack Overflow and expect an answer in a finite time? Is there a playground available so you can play with existing API endpoints, understand how they function, and see, are they really suited? Is documentation linked clearly from the code examples and back? So also does the documentation, so the documentation should link to the code should link to the documentation. Wherever you start, you should find everything. Final point on level 4 is API evolution. Can a developer or somebody using it also provide feedback? The reason we've got Hylke involved. If you're missing something with SensorThings API, tell Hylke and he will get it somehow ideally introduced into upcoming standard versions. So final level of our evaluation criteria all developed. This is now the absolute ideal system we dream of. Is all the code you need for deploying and using and developing there visible? Can you clone it? Is there a bug tracker available where you can also input all of your issues, suggestions? Are the licenses really clear? Are there any patent claims? Are there any problems with uptake and reuse? Is there a clear development roadmap so you know if there's some upcoming functionality you will be needing in your system? Is there a way of ascertaining when will this be available? Is it suited for linked data? So can this also be used to shift to a more linked data friendly world? And finally, is there a solid test framework available so you can really see if an API is conformant? So these 5 levels give us all the questions which we are evaluating against. Then we have our evaluation methods. So these are again based for different audiences, but for all of the evaluation criteria I showed you for the 3 stakeholder perspectives, we've then gone through and chosen which of these evaluation methods is most suited. So the one is the heuristic expert evaluation. Here, domain experts from the project team and data provider staff basically look at the issue, discuss it, and come to a decision. For some of the evaluation criteria, such as does the API provide JSON or XML, we don't need interviews. We look at it, we see it, we can say yes. So that's the heuristic expert evaluation. Peer review was an interesting concept, which I pulled out of a further publication, where they have a nice process, which is, it's based on code review, but they apply this to API development, where a specific aspect of the API is then reviewed in a structured manner. So one person explains it, and then the other review, you've got various roles defined, and using this methodology, one should be able to get fairly strong feedback within a limited time. This is still one of our upcoming steps. Then we've got various stakeholder interaction methodologies. The one is more in-depth stakeholder interviews. Various of the people involved within the project, either deploying data or also using data, will be interviewed by our project team to really understand how was their experience working with this. The final evaluation method is stakeholder questionnaires. And that's the reason I've been bugging you with the questionnaire and will continue to do so. And why I'm very thankful to all of you for providing answers, because we need this for our evaluation methodology to really show that this makes sense and that we can recommend this to a wider audience for uptake and Inspire. So pulling all of this together, as mentioned, we've got our stakeholder perspectives. We're looking at it from the API development point of view, from the API deployment point of view, and from the API use point of view. We have our 5 levels of evaluation criteria as defined. And we have our 4 different evaluation methods. Here we've done a basically 3-dimensional matrix, gone through, determined which of these methods are most suited for which stakeholder perspective and which of the criteria. And the full details of that, there's a link at the bottom. Again, the slides will be available. You can download our first deliverable. There you have all of the details. So that's the end of the evaluation methodology. Now going on to our deployment strategies. So again, we've got a link down there. I'm not going to go into any details on this. We have cool deployment strategies for how to get your things online, both for OGC API features and SensorThings API. The details on deployment will then be after the break. Hylke will walk you all through how to get your own SensorThings API system online. And OGC API features is a different talk. All the details are down at the bottom in the links. Okay, next step is the deployment of endpoints. Now we finally get to the fun stuff. So what have we done here? I tried to figure out what do we call these different groupings, where we always had a focus on co-located and complementary data sources. It doesn't make sense to have air quality in Spain and something complementary in Sweden. I can't cross-calculate that. So the 4 groupings we came up, the first 3 were actually the original project plan. The 4th one came up during lockdown, a mixture of boredom and doing the right thing. So the first one we've named Airy Austria. That's based on the air transport information we have coming from Austria Control, and will be complemented by meteorological data from the Austrian Meteorological Agency. Second one is the Urban Data Platform Hamburg. There we've got all sorts of smart city sensors together with the road transport networks. So there one could do some very interesting applications on smart navigation, and I think you can see when which charging point is free and how to get there fastest. The third foreseen data nest is the Franco-Germanic Flow. That's where we've got the cross-border water data. We've got surface and groundwater quality, quantity, flood zones, all of that on both sides of the Rhine. One of our big challenges now is actually getting those linked together in the middle, because they both have the Rhine as an object. They spell it a bit differently because the French spell it French and the Germans spell it German. And they don't really know that this is the same object. But these are the details we will have to be dealing with then. Okay, and the final one is, as I mentioned, came up during spring lockdown. It started with realizing that there's strong links to air quality, and hey, I know where it is, and it'd be really cool to put this online via SensorThings. So we did. And it also really showed both the power of standardized data models. Since it was coming from the Inspire model, the structure was basically how we needed it. And Frost is a beautiful technology, very simple to deal with. So the first prototype going from the Austrian air quality data to a SensorThings implementation was up in, I think, 2 or 3 days. Based on that, we then started scratching what is happening also generally with COVID, and found a very nice SensorThings endpoint, which was put up by a student at the Technical University of Stuttgart. And he realized that just because it's called SensorThings, you don't really need a sensor. And that the type of data which is produced for, let's say, the number of new COVID cases in a certain place is so similar to a measurement or an observation at that place. And so Joe basically took the SensorThings technology, deployed a Frost endpoint, started importing data from both the Johns Hopkins repository as well as from the German Robert Koch Institute, has that available online in real time, does regular updates. We've been mentoring a bit and providing support on how to best structure that. So now we had the air quality and the COVID case data, and then I realized we actually need demography, because if I know the number of cases, it's nice to have, but 1,000 cases in a big city aren't that scary. 1,000 cases in a rural community are a serious problem. We need the population of the administrative unit. And for that purpose, I then access data available from Eurostat. So there we have, for NUTS regions 0 to 3 across all of Europe, we've got the total population and the population density, and we now have a further experiment running with Statistics Poland. There we have actually the more in-depth demography on the 1 kilometer grid. So those are our data sources. And here you can see some of our more dynamic bits. Here we've got our hydro things going across France and southern Germany. Then we've got our air things going across all of Europe. We've got the COVID things basically around the world. And the demography things are also all over. So I would say we have a fairly rich data landscape now based on SensorThings, and it is available for you all to play with. A bit more detail on the nest. So we've got the Airy Austria. Here you've also got the endpoints available. So we've got both a WFS2 and an OGC API for the air transport networks. The meteorological data we've been having some issues with. We're still working on that one. Urban Data Platform Hamburg, we've got the endpoint for all of their IoT data. We've got charging stations for the cars. We've got the bike sharing stations. We've got data from the energy campus, and traffic lights density is coming online. So there's a lot of cool stuff to play with there. Franco-Germanic Flow, we've got the mix between the French Geological Survey with the French Office for Biodiversity, and they've got a joint work on getting data online. Their Inside Information Center has been doing really strong work on getting emerging technologies really functional and online and providing data. That is being complemented by data from the Environment Agency in Baden-Württemberg, which Fraunhofer IOSB has online, a SensorThings. So there we've got all of the ground, surface, and whatever. Here we've got a bit of an overview of what all we have. So here we've got the various stations. I don't understand the details, is then for the water people, but we've got our rivers, we've got our water quality and quantity stations, we've got time series coming off of all of it, and we have flood regions. Finally, the Ad-Hoc Nest, we've got our air things, which are harvested both from the Austrian Environment Agency and from the EA. We've got the COVID things, and then we've got various demography things approaches. So that completes all of our endpoints. All of these are available from our site. They're publicly available, and they're foreseen as a playground, so you can start playing with stuff and understanding what can this technology do for you. Guidelines, technologies, lessons learned. So what have we been setting up for you here? This is a screenshot of our website. Hylke will be then really driving you through this, but this is where we've been collecting all of the little bits we've been seeing as missing from existing websites. As you see on the right side, we also have the data nests heading there. That's where you can find direct links for all of the endpoints I've been showing you. And if you go on the side, you then the menu expands. So you've got all of these details. Here we've got the OGC API features. Everything which I've been found missing from GeoServer configuration is there. It's now done with a nice, simple example, so you don't have to learn GeoSciML in order to understand GeoServer mapping. And also for people working on GeoServer, I've been setting up quite a few of the configurations we've made available during the API for Inspire project are available online. You've got the app schema mapping, you've got the database configuration, take it and have fun. Now we're going into the details of what we have for SensorThings. There we also have a beautiful tutorial showing you exactly how to work with it. This has actually been extended. This screenshot is from a few days ago. Hylke has been very busy. So basically anything you ever wanted to know about SensorThings and didn't dare to ask, go to this page, click your way through, you will find it. And finally, at the bottom, we also foresee various demo maps. So this one is showing our demography things. And depending on your zoom level, you have the various NUTS regions. Here's at NUTS 0, so you just have the countries. Click on a country, you get all of these statistical metrics. And if you click on one, you get the time series for the population, the female population, whatever that is for, I think, the last 10 years. So finally, we have to provide evidence for good practices in Inspire. That's what we've been doing with this work. We've got the candidate good practice status we got a few weeks ago at the Inspire MIG-T meeting. We've been getting all of these endpoints online, and thus I think we have made good progress on showing that APIs are really well suited for Inspire. That brings me to the end of the API for Inspire tasks. Now we get to start going into the details of dynamic data and SensorThings. So, observational data. I mean, in classic spatial data, one has some feature. The smiley face on the left is your feature, and it has some attributes attached to it. In this case, we've got the color is yellow, and the expression is happy. This is how simple features work, and for a lot of data requirements, this is all you need, and it's great. You just have your feature with a few flat attributes, done. Why do we have all of this observational data? What are we adding? We're basically adding a lot of observational metadata. So I mean, yes, we know that the color is yellow, but how was this done? I mean, it could have a very different quality depending on what method was used for this. And you'll also have a different type of result depending on how were you comparing. If I only have a set of 6 basic colors to compare it to, I will get a different value than if I have, I don't know, the full spectrum of Pantone colors. So that gives you relevant information on what you're actually getting. Same thing pertains to the expression. What am I using to really understand that this face is happy? So this gives you a lot of really important information you need if you want to do high quality data processing on it afterwards. The problem you run into is when you get confronted with a pile of these. Oh my God, what do I do with this mess? And most people who want to analyze data really just want some simple flat tables they can pipe into their R software or analysis tools and get on with it and do their work. So I mean, they see this and they're all happy and excited and they start working on it, and then they realize, oops, but I do need to know a bit about the quality or the methodology or what is even the unit of measurement on that column. And this is where we've realized SensorThings brings a lot of support because we've actually managed to bridge this gap. We've got the tricky data model behind it. So the data model thing I was showing you is sort of the core of observations and measurement SensorThings. At the same time, once you can structure it this way, you can store all of the relevant meta information you need. And when it comes to accessing the data, if you want a flat table, you can choose the CSV output format and get a flat table and analyze it in R. I think we've really nicely bridged that gap from the complexity you need to with the simplicity you want. So what is the SensorThings API thingy? It's the successor to the sensor observation system. It is RESTful, it uses JSON, it's based on O&M. In contrast to the normal OGC APIs, it's based on the OASIS OData standard, which allows for really powerful queries where you can take the entire data model really into account. You'll see details of that later and then understand why I'm so excited about this. It's scalable, so I mean we have enough deployments by now to see it scales over thousands of stations and millions of observations. And it takes a while to get your brain around, but it's understandable. You can really walk through the data model and it's all there. So this is our basic SensorThings data model. And to explain this a bit better, these are the basic classes. The difference to normal OGC models is we actually have a standard data model behind this API. And the data model consists first off of a thing. This is what your sensor is mounted on. This is often a room. This room has a location. And this room can have different locations is because things can move. So if my thing moves, I add a new location. Via the historical location, I can even show where was the thing last week. The thing is the first main concept together with its location. I'd say the second main concept is the observed property. What am I measuring somewhere? Here, the observed property could be the temperature, it could be the ozone concentration, it could be the height of a river, it could be the population of a nuts region. The third main class is the sensor. This describes the measurement device or can also be abstracted to the measurement methodology. How was this observed property somehow ascertained? Did I use a simple thermometer? Did I use something electronic? That can all be packed into the sensor description. These bits now get linked together. The data stream concept is where basically the start of a time series, where you can say, for this thing, for this room, the observed property temperature is being measured by this thermometer, a bit of more metadata. Onto this, we link the observations with the values. And here you can provide any type of values. It could be numeric, it could be a string, what you want. The final piece of the data model coming here down off the bottom is the feature of interest. That's actually the explicit object being measured. Going back to the example of a thermometer in a room, the thing would be the room. The feature of interest is really the air bubble around the thermometer. And I mean, if you have a large room, you can have a thermometer at each end providing quite different values. So it's important to split these two concepts. This is the basic SensorThings data model. Now I'm going to take it a step back and introduce you to the Inspire data model, which is what we're trying to align this to. So this is the very abstract Inspire environmental monitoring facilities model. And since I know none of you can read this UML, we're going to go through and make this a bit easier to read. So it starts up here, we have the environmental monitoring facility. Attached to that, we have what we call the observing capability. It's basically a potential observation. What type of observations can this environmental monitoring facility provide? And this links to one feature of interest. What are we measuring on? One property, what is the observed property we are measuring? And one process explaining how this was measured. And then finally, we provide an observation that links again to the feature of interest, the observed property, the procedure, and that then also provides you with the result. So this is the basic Inspire environmental monitoring facilities. I'm going to make this a bit shorter to make it easier to read because we're going to need this picture a bit longer. So the environmental monitoring facility, we often reduce just to EF. The observing capabilities, we've shortened down to ops caps. The feature of interest is usually referred to as the FOI. The ops prop is the observed property. The process is the process, and the observation is the observation. So now we have it all in a nice shortened term, and I'll also take away the various role names. This is the very abstract core of the Inspire EF model. And the challenge was, how do we now align this with the SensorThings model? So let me shift that up to the corner. And now we've got our SensorThings model. And again, looking at the Inspire model, we'll start with the environmental monitoring facility. That corresponds nicely to the thing with its location within SensorThings. So where I was describing earlier, that can be the room where your thermometer is in. It can also be the monitoring station where you have your various measurement devices. The second step are these observing capabilities, the potential observation on an environmental monitoring facility. That is covered by the data stream that links together exactly the facility with the various observable property, process, and feature of interest. The process is the sensor. The observed property is the observed property. The feature of interest is the feature of interest. Those are fairly simple. And the observation itself is more the linking of both the observing capabilities, which is a data stream that's the head of the time series, together with all of the individual measurements. But based on this mapping, you can see that all of the concepts from the Inspire environmental monitoring facility specification are fully supported via the SensorThings spec. Going into more detail, we've got the class level mapping, but what do we do with the various detailed the class level attributes? So we have various mandatory attributes, for example, here on thing. We have the measurement regime, we have if this was the mobile facility or not, and we have when was this facility in operation. And where do we put this? We need to put them on the thing. And there we have the insight. Let's put them in the properties of the thing. So the thing, it has a few basic attributes, and then it just has a property slot where you can add any JSON object. How do we do this? We've got on the left, we've got the requirements from Inspire. on the right, we've got where I align this to various SensorThings attributes within the data model. So the local ID from the Inspire ID gets mapped directly to the ID of the SensorThings thing. Same happens with the name. We've got a name for the thing. We can just use that. For the other attributes, we just define attributes within the properties block and can provide them all there. So we can provide the full breadth of data which is required by the implementing rules from Inspire and pack them down into this properties block, and therefore we're providing everything despite not using the exact UML model that's been defined for Inspire. And the trick I've now shown for things, that applies to all of the classes we've been discussing. That's one of the bits I was saying, that the advantage of having Hylke involved in the OGC is that originally the properties were only available for thing. And one of the updates we got into the 1.1 version is adding this properties extension point to all SensorThings classes. So any additional information which the implementing rules require for some place are covered. You can put them in there. And we've been formalizing this as an Inspire good practice. We've done a paper on the mapping for it that's available under that DOI. Not a DOI, but it's available there anyway. We got candidate good practice status at the MIG meeting in October. There's more information at the GitHub link shown, and we're hoping for endorsement at the upcoming MIG meeting. So next step is, how does one really work with this OGC SensorThings thingy? So we have our model, and then you've got an endpoint, and that gives you the JSON you see on the left. And what does the one thing have to do with the other? So we've got, let's start at the top with the URL. We've got the base URL of the server, and a SensorThings endpoint always ends with the version number. So the v1.1 is the end of the base endpoint string, shows that the SensorThings instance there is already on version 1.1. And then if you look at the names provided under these individual objects in the JSON array, we start seeing that these are very similar to what we have in our data model. So here we've got data streams, and that's the data stream. And the features of interest is exactly down here, the feature of interest. Locations is that. One thing to look at very carefully is singular versus plural. This is one of the big gotchas. If you look in the data model, everything is singular. We have data stream because we are talking about one object. Here in the name, we are talking about data streams, many of them. If you go to the URL below that, you will get all data streams provided by that endpoint. Most places, the S goes at the end. The one bit which gets me again and again are the features of interest. Here, the S gets slipped between the feature and the of. If you remember that, and remember it's plural, it's a logical way of pluralizing that. And take-home message from this slide is when you go to an OGC API, an OGC SensorThings endpoint, you'll be shown this array of individual collection endpoints. Each has a name, each has a URL. Now going into the details of that structure. So again, as stated, you've got the version number is the end of your URL path. That provides you this collection index. It provides you the different types which are available at this endpoint. If you, after the slash, put the name of your collection, you get all of the entities in that collection. So there you would get all of the data streams. If at the end of your collection name, you put round parentheses and an ID, you get that individual. So let's make this a bit more concrete. I know collection is an abstract concept here. Now we've changed it to data streams. So if you click on this first link you see, which at the end of the v1.1 has /data streams, you get all of the data streams in the collection. suddenly it looks like this. Here we've got the first data stream open, and then we've got a lot of them down there. And looking at the first one, it has the ID 17087. If I put that in the ID at the end, I get exactly that one object. So this is the very basic way of requesting data. What else can we do with an endpoint? We can create a new entity. We can update an existing entity. We can just totally replace an existing entity, or we can also delete it. So again, to make this more concrete, I'm going to the example of things. So to create a new thing, we have to use HTTP post. We post to the normal things endpoint, no ID yet because we're creating a new thing. And we post this piece of JSON as an example to the SensorThings server. This would create a new thing, name my kitchen, description of the kitchen in my house, and we know it has an oven and 4 heating plates. If we send that with post to the things endpoint, a new thing will be created, and you will get the thing back with the identifier. Second bit is how to update an entity. So I can just change the name of this kitchen object. I need to put the ID of the object into the end of the string that knows I'm modifying exactly this one object, and then the name of that object will be changed. Third bit is really replacing an entity. So here I've got an extended JSON type, and I'm just going to overwrite everything under thing 1 with this new and improved kitchen. Finally, if I want to delete it, I don't need to send anything. I just put in the URL with the ID, and I send a delete via HTTP, and that entity is gone. A few more bits on tailoring SensorThings responses. These are sort of the classic bits you have in most APIs. So you've got a top, where you can specify how many responses do I want. You've got a skip, which you use for paging. So if you know top is 100, I've got the first 100, I want the next 100, I tell it skip 100. Count gives me the number of objects which I would be getting in the response. This is often useful for if you know that a lot will be coming. First you can find out how much is coming and then figure out the rest. Default count is false, but it is useful for you, set it to true. And the fourth sort of housekeeping response is order by. This way you can have the responses, all the objects sorted by one attribute. Now getting to the fun, tricky ones. We've got the filter flag, which we can use to really filter which entities we get back. Yes, Simon, we will be doing a break shortly. We've got select, which lets us choose which attributes are going to be provided. So if you've seen some of the objects have a lot of attributes, you don't always need them. You can use select to cut it down just to the attributes you want. And expand is a really cool thing. Expand lets you then include neighboring classes. So a data stream could then expand to also provide its observed property. And examples of this, so under filter, here we're showing all observations where the result is greater than 5. As you see, the result here is 10, that's greater than 5. Further ones would be down here at the bottom. With select, select is the one where we can chop down what do we really want to see. So here we say we just want the identifier and the description, and therefore we get these teeny tiny things instead of the full breadth of the thing. Expand lets us go from one bit to the next. So going to the previous one, we have our things, just the ID and the description. We're building on this. So this is now the small part at the start of the URL, and we're saying actually for each of the things, expand the data streams. I want to know what is attached to Camping Lantern 1. And I find that I have one data stream which provides temperature measurements and some more down here which are closed. So that gives you a first basic overview of how one can use SensorThings API to really do very powerful queries on the data. So, summary. SensorThings API, at least from everything we have seen, is really ideally suited for the provision of dynamic data, both within Inspire and going far beyond, as things like our COVID things are showing. The evaluation process is still underway, but just the feedback we've been getting working with our data provider shows that it does make things easier on all sides. The API for Inspire project has gone a long way to demonstrate both the flexibility of the technology and as well as supporting the uptake of via data providers across Europe. And we would much welcome any support that participants can give us that we are finally certified at the upcoming MIG meeting as a final Inspire good practice. For the end of this block, I would now like to take you back to our survey because I've got some more questions for you. It's also making sure that you have been paying attention.
This is the test.
Yes, this is a test. So, next question. I'm assuming now that everybody who is still here knows what an API is.
We did not lose too many people.
Okay, I'm going to go to the next question regardless because this is actually very similar to the first one. Sorry for people who I'm not chopping off. I think you can still answer anyway, and I will move on to the next one. So, sorry for running over in my presentation. Okay, how did your APIs happen? I mean, we've seen very interesting approaches on all levels. Some are very well thought through, some sort of evolved to become what needed to be there, and some of them can only say they happened by accident.
Okay, so far no accidents, that's good.
Okay. How did our original formulation for that go? The written by monkeys, managed by clowns?
Yeah,
oh, we got one.
Yeah, we've got an accident.
Okay, but it shows that we've got some fairly strong trust in standards. People do use cases.
Yeah, of course, those first two are not mutually exclusive. You can have something based on standards that is also based on use case.
The problem with the ones that happen by accident is that those are the ones who then end up having the big uptake, and they then evolve and they then get unmanageable.
Yeah.
Interesting will also be if the in-house usage ones ever get X-house. Okay, but it's nice to see that standards and standardized development is accepted in this community. Further, but this is should be mostly pertaining to SensorThings API, the reason you're all here. If you're having problems with the documentation, please say no here, and that means that we have some more homework. Or short feedback to this also, if there are any bits of the documentation we are providing which is unclear, please tell us. I mean, we no longer see anything because we are going blind. And the other thing is we know what we're writing, so we tend to understand what we think we thought. But for the case where you don't understand what we think we thought you might be thinking, you have to tell us. So any questions you provide will not just help you, it will help other people, because then we will update it and the people who don't dare ask will also get it answered. Okay, I would say the voting is stabilized on this one. This goes into the bit where I was saying, please tell us what you're missing. We can only help you if you tell us where to help. Okay, well, I think a lot of the documentation Hylke has been working on the last weeks will be coming in very handy. Yes, we've got lots of examples. I personally adore examples, so I've been making sure we have them everywhere. Hylke, do you see anything we haven't covered in the current suggestions?
It's shifting around a bit much still, so.
Complex queries examples you finally did last night, I think.
Yes.
Okay.
Oh, there were already some.
Okay, but I think this means the audience will be very happy with the further pieces.
Tutorials, that's new.
Okay, well, I mean, basically what you've been doing is a tutorial and it's complemented with sandboxes, exactly the tryout installation. We even have a Frost endpoint that you can do anything to. And do you occasionally just delete the database on that one, or how do you keep that one sane?
Yeah, that's occasionally I just delete everything in there.
Okay, so we even have a sandbox where you can do anything you want and there will be no issues. Okay, I think that's the last one for this. Oh, no, we have, could you find example requests? Everybody who says no here has to listen to Hylke this after, in the further blocks.
Well, this type, of course, the relevant example request is always difficult because there are always use cases we have not yet foreseen.
But again, it's also a request to get back to us, tell us what have we missed.
Exactly, that's where the GitHub also comes in. Everybody can ask questions there.
And you have to help us help you. I think anybody who's gotten in touch with us knows one gets very quick, very unbureaucratic feedback. But if you don't ask, we can't answer. So looking at this right now, I'm assuming a lot of people need to ask their questions.
That's good.
But that's why we did this workshop.
Oh, there's another one.
Whoop. I should have written along what questions I did here, but it will soon be done. Okay, I was wondering where the no's were, because with all the no's in the previous slides, I'm still expecting a few more, or we're seeing the difference between the people just requesting data and the people trying to input data.
Yeah, of course, big difference.
Okay, but okay. More people are daring to admit that they don't know and are therefore offering to ask good questions during the remainder of the workshop. Okay, I would say this is also basically quieting down. The others are preferring to hold their tongues. Okay, everybody can take a short break. And after that break, we will be continuing. Quick question, Simon, do we do discussion now or do we let people escape quickly? I think we will just try and do more discussion during the other presentation.
If there is any discussion at that point, I would recommend it to hold it now. If there is no questions or comments, then save it for later. But there are no questions at the chat box at the moment.
Okay, the question from Martin Duchinja on which Inspire themes SensorThings could be used. This is a good question. I mean, we've been setting it up for SensorThings. That has been my home base for ages, and for there, it's obvious. At the same time, we've been finding more and more interesting applications for it. Things like the demography things we've been doing. That's based on the fact that the Inspire models there have been basically agreed are more or less corrupted. They're not working well. And we've done this as a first proof of concept. We're not sure where this is going. But basically anything, to put it in a nutshell, anything where you've got some spatial object where you have data changing over time. That's the core of what we're trying to describe by dynamic data. So that's one reason it applies well for demography. One has yearly values there. I wouldn't know how to make a static feature which has this as attributes, or I get very strange attribute names of population 2014, population 2015. It would be nice to provide that as a time series where I can devolve that to an array. And to my understanding, if we get the good practice, we can also apply SensorThings to other Inspire themes wherever it makes sense, and we provide the necessary data. Does that answer the question, Martin?
Yes.
Other questions?